Hi everybody. Just to introduce myself, my name's Levi. I'm the Solutions Engineer at Mux. And today I'm going to bring to you a bit of a story from sort of the Mux archives, if you like. And the story is going to be about just how Mux monitored the quality of experience for the largest live stream in history. What does that mean? So I'm going to go into a bit more detail, but to tell you really what I'm going to be talking about today is that I'm going to talk about the challenges encountered by Mux in testing and scaling the infrastructure. So I'm going to touch on some topics like what is Mux data, our real-time infrastructure, some details on the largest live stream in history, and sort of the main juicy points here on the load testing and some of the issues that we actually faced trying to do this. So actually what's probably makes sense here is to tell you a little bit about Mux data so you can understand a bit of the issues that we face later on. But so Mux data is a tool that monitors the quality of experience of live sports streams in real time. So we help broadcasters and stream owners answer questions like, why are my users rebuffering? Why can't they play back the stream? And what errors are they having and on what device? And just to emphasize on why QOE, quality of experience, is important. So to tell you just a bit of a story, so Mux has monitored the last 5 Super Bowls, right? And these Super Bowls, we see about 6.5 million concurrent viewers. So that's 6.5 million people watching the Super Bowl at once, and that was monitored in real time by Mux. So let's just say, this didn't happen, but let's just say 20% of those viewers actually failed to play back the live stream, right? They tried to press play and they saw a spinning wheel or they just saw black screen. They couldn't see anything. So this is obviously bad because it's a live event, live sporting event, and they probably have some very expensive ad slots, right? So without QOE monitoring, and when I say QOE, of course, I mean quality of experience monitoring, they could lose revenue because with this real-time monitoring, they could see in a chart like this, users failing to play back, 1%, 2%, and they can act in real time to try and stop it from getting out of hand and impacting lots of users. So that's why it's an important thing to have, specifically, of course, in live sports. So to go in a bit more detail in some of the tech side of things, so what we're looking at here is Mux's real-time architecture. So we have 2 sets of data architecture. We have historical data, which is data that you can revisit back once a viewer has finished watching. But what we're focusing on today is this, which is users who are watching right this second. Like I mentioned, 6.5 million. We want to know about them, okay? And this is the infrastructure that Mux has to actually monitor those. So at the beginning, we have the player SDK. So this is Mux's SDK that you put on the client. And then that player SDK monitors the viewer's session. And what it does is every 10 seconds, it will send a heartbeat of data to Mux throughout that user's viewing period. And that heartbeat contains a bunch of data, and I'll show you a little bit of what that data is. But that heartbeat sends data to our collector or load balancer, and then that gets forwarded on to processing via Kafka. And at the processing, what that means is that we're taking those 10-second bits of information and trying to compile it into, to make it understand that one user's experience. So then we write it to our real-time analytics dashboard, a real-time analytics database, and the database of choice for Mux is ClickHouse. So this is our real-time database that we use. So we're writing those heartbeats into ClickHouse to our database, and then our dashboard will query ClickHouse in real time and present that data to the customer. Okay, and all in all, from that player to when you see it in the dashboard, it should be about 20 seconds. So we're as close as we can get right now to real-time data. So this is it. So this is basically, I'm not sure if you can really see it, but this is an example snippet of the data that I mentioned that is sent every 10 seconds. So in this example, we're sending a bunch of metadata, but some key play events as well. So those events that you see on the right are actually being sent from the player. So for example, if any of you had paused, played, and skipped a video, the next 10-second heartbeat, we would see those events sent to Mux. So that's how we work from the client side. So I mentioned earlier that we'd monitored the Super Bowl, right? And that hit 6.5 million concurrent viewers. So of course that meant there were 6.5 million individuals sending a 10-second heartbeat to Mux. And then recently, I'd say sort of recently, but last year, we closed a pretty big customer. And I think, the sales team were, of course, very happy with that. And till we sort of found out some of the numbers that they wanted to give to us. And actually, what it turns out is that they wanted actually for us to prep for 50 million concurrent viewers. So if I can actually emphasize that for a second, 6.5 million people was the biggest event Mux had done. And that was 6.5 million people sending 10-second heartbeats of data. And now we're being told, as I mentioned, sales team happy, engineering team, we have to figure it out. So now we're being told that 50 million concurrent viewers we're going to have to support. So that's 50 million individual viewers all sending that 10-second heartbeat of data, right? So you can imagine that's a challenge. And again, this was an estimate given by the customer. And this was actually specifically an estimate for the final of the cricket. So what I want to do is just give you highlight some post-event numbers that we actually saw. So for the cricket, we monitored 60 events with peak viewership ranging from 8 million to 30 million. So we didn't hit the 50 million concurrent viewers. The final was actually rained off and they had to replay on another day, of course. But even the least favorite cricket match, had more concurrent viewers than the Super Bowl. So we done that. And that means we processed data for almost 17 billion views across all the events. And when I say views, I'm talking individual user sessions. So if anyone here had watched the cricket, you press play, you watched it, you're being counted here. So, and then the system supported high volume, bursty traffic up to 3 million requests per second. And each event ranged from 60 to 150 terabytes of data, totaling 7 petabytes of data that we ingested just for the cricket, just for those 60 events. It's pretty, yeah. And of course, when you get to these big things took a little while, and then we finally got the dates. And apparently, we only had 6 weeks to prepare, which adds to the kind of insaneness of trying to attempt to do this. And we hadn't, if we had a little bit more time, of course, we would spend a lot more time trying to think about how we could maybe re-architect a lot of our platform to actually support something like this. But of course, we didn't have that much time, so we really had to kind of think about how we're going to approach this. Okay, so let's kind of like kick off the start of the journey now that we've been told there's 50 million, we have to support it. Now let's kind of take you through what we had done. So firstly, of course, as the engineering team should be doing, was before we can even start to build anything, we should probably define success metrics. Like, what does success look like to us when we're scaling to 50 million concurrent viewers, right? We can't just say, yes, it doesn't work and makes everything fall over, or no. We have to be way more granular. So one of the most important metrics that we track, and actually is like the key value of our real-time data, is the real-time processing lag. And when I say that, I mean, as I mentioned before, from when the users press and play and that data is there to when we see it in the dashboard, that is what I'm talking about here. Because if that data is 1 minute behind, 2 minutes behind, that's not that great for real time. If something's happened, you cannot wait 1-2 minutes. So as I mentioned, we actually sit currently around 20 seconds for that. So this was super important. And we had a few other metrics that these all really go into the user experience, right? We didn't want to, read query throughput. We had to put some values to, for example. So I don't expect anyone to kind of read from this, and I'm not going to read it at you. But I did want to just highlight, again, the peak minimum real-time processing lag to emphasize just how important this metric it was to us. So we set the processing lag at about 30 seconds max for when we hit 5 million, 30 million, and 50 million. Because that's a number that makes, a lot of sense to us and to our customers. So before we can even get to throwing some load tests at our systems, we still had one, or maybe a couple more steps to go before we could even get there. So one of the things that we had to work on was that the tooling that we had built already just wasn't fit for purpose, right? So we had built some tooling for the Super Bowl, which helped us generate load tests for this area of the ingest pipeline. So we were able to create some, fake viewership in the dashboard based around the database area. But of course, when you're starting to scale to those levels, you probably should check some other parts of the pipeline. So we needed to build tools to test this area of the pipeline, because this is not what we had. And actually, we looked at trying to find an off-the-shelf solution, and we couldn't really find anything that would help us with the scale and some of the requirements that we had. So we had to build it, and of course we did, which is great. Cutting into that 6 weeks, but we have to start somewhere. And then lastly, before we even start to test the load, we realized we probably should create a single tenant environment for this customer, because Mux today is a multi-tenant solution. So the resources are shared between customers. But what we didn't want to do, of course, was start to throw crazy loads and have to think about other customers and what if it impacts or increases the lag time. We just didn't want to do that. So for the first time ever, we created a single environment, single tenant environment for this customer to keep them isolated. So we are finally there. We're ready to start testing. We have our tooling. We've defined our metrics. Like, we know what we need to be doing. So let's start. So as I mentioned, we've deployed our scripts. We started to test load. We're throwing everything we have at it. We're waiting for it to have no issues whatsoever, which of course never happened. So we ran into some issues. Of course we did. And I've picked 2 of those issues to kind of run through today, because they represent sort of some of the work that we'd actually done. So back to my favorite graph here, or table, or whatever it is, diagram. So this is issue 1 out of 2, right? So we were running our scripts, throwing load at this, and the first place that we ran into a bottleneck or an issue was here. So at about 6 million concurrent viewers, when the test got there, we started to see some issues with our database. And what did that look like to us? So we actually saw an increase in read lag. Now, if you remember just a couple of slides ago, I said that the KPIs that we set were about 30 seconds of read lag, and we didn't want that. And actually, only at 6 million did we start to see it nearly hit that already, and we only had 44 million left to go. So clearly that wasn't going to work. So what we did was, of course, made a bunch of changes to the database. So what I've put up here is going to be a bit of a timeline against the load that we were at and the change that we applied. So at 6 million, we added read replica sets to balance the read load, which helped us with the read lag. We then got to 10 million, and that took us to 10 million. And we then started to see some lag again, and we then modified the database to partition on more granular time intervals, which helped with reducing the query time. That took us all the way to 12 million, where we then had to, again, we started to see some lag and it wasn't doing particularly well. We then vertically scaled the database pods to maximize all CPU and memory resources, and that actually worked pretty well up until about 28 million concurrent viewers, where then once we got here, we ended up with 4 read replicas. We went from 16 to 30 database shards, and it actually worked really well, and it managed to take us way beyond this. So this was all the work that we've done to our database, and we are seeing some good numbers in the dashboard. So now we get on to the second issue here. And now that we know that we've managed to kind of fix up the database a little bit here, we needed to then test, and then we ran into issues in this part of the workflow. So on our load balancer and collector area, and we got here, it took about 30 million concurrent viewers before we started to see issues on the load balancer and collector. So before I go a bit more about the issue that we had, it probably makes sense for me to show you what's inside our collector. This is where the magic happens. So we have the player SDK and heartbeats, as I mentioned earlier, 10-second heartbeats sending snippets of data all the time. We have within our collector, we have a server that accepts those beacons in. It writes it to a channel that we developed an application in Golang, and then there's a Kafka producer that reads from that channel and forwards it out for processing, as I mentioned earlier. So where are we at? Okay, so now 30 million concurrent viewers. What are we seeing? Well, actually, we're seeing heartbeats from the SDK. We're getting rejected above 30 million. So whenever they were coming in beyond 30 million, they were just being dropped and dropped and dropped. And actually, it was quite difficult for us to kind of pinpoint exactly what was going wrong, which obviously meant that the data in the dashboard was incorrect, right? So we just saw a plateau at 30 million and it didn't go anywhere. So the issue actually was that the data was being written from the beacon receiver to the beacon channel faster than the actual Kafka producer could even pick it up and then forward it on. So they would get to the channel and just not be picked up and dropped, and that just happened after 30 million. Unfortunately, the fix was easier than trying to figure out what was going wrong, and all we had to do was we increased some of the threads, and it worked, which was fantastic. And I just want to say, we did it, and here's a screenshot from the cricket final. We can see, this is a Mux data screenshot here. We can see at 32.1 million concurrent viewers for this final, and all of the work, of course, that went into this. All of those issues that we overcame allowed us to do this. And I just want to say, 32 million in April is nothing now, right? 59 million CCV now as of the Cricket World Cup final. So of course, it's just going to forever, keep growing and growing and growing. So, but yeah, look, thanks for listening. Hopefully the story from the engineering archives was a good listen. So thank you.